in this second classification regarding whether to install Kubernetes over Baremetal or VMs for telco intensive input-output workloads, we are not gonna just consider CPU and memory as in the previous classification, but we are gonna also consider how networking is implemented, okay? So, in the most basic case, what we have is the networking layer of Kubernetes that is gonna rely on the physical port of our server, okay? So it's gonna be medium performant. In the case of having EPA Kubernetes over bare metal, we will have this same networking layer of Kubernetes, but in addition to that, we can have our Kubernetes to have control of physical ports with SROB capabilities and to be able to provide these SROB ports to our pods. So our pod can have multiple interfaces, for example, two interfaces. One of them could be the management interface based or using the regular Kubernetes networking solution, but the second interface that we will use for data could be an SROB interface, a dedicated SROB interface. So in this case, we will get the maximum performance for these telco workloads. In case we're using VMs, actually I'm going to explain both of them at the same time because it's exactly the same than before. We will, in addition to the limitations of having or using emulated resources, we have that now we have a networking layer, the Kubernetes networking layer, that is going to be placed on top of the Beam networking layer. So it's going to be really inefficient because our traffic has to go through both SDNs prior to arriving to the port, and from there going to the switches. This is the reason why I'm saying that this EPA Kubernetes over EPA VM, that in the previous classification was considered good performant and green, I'm now considering it as bad performant. Why? Because we're using this stacking of SDN layers, and that's going to be really inefficient in terms of how our traffic is going to go through the system. This could be enhanced changing from red to or for bad to medium performance if we were able to remove one of these two layers, okay? And that could be done in case the Kubernetes vendor and the Beam vendor are the same and they are providing a proprietary solution to allow the Kubernetes to be directly using the Beam networking layer, but it can in general be done also, for example, using the Courier project that allows us to implement a networking layer for Kubernetes that is really using the Beam networking layer, or Neutron in case of OpenStack, okay? An alternative or a different setup that will allow us to get a medium performance would be in case we are using EPA Kubernetes over EPA VM, that our port that we are using to rely for our Kubernetes networking will be an SROB port in our VM. So do not confuse this SROB with this SROB. I mean, in this case, our Kubernetes has the control of the physical port and is able to provide the SROB to the pod. It's not the case that we have in here. In the case we have in here is that our VM has the SROB port. This EPA Kubernetes is not able to provide this SROB port to our pods because we only have one SROB. Okay, so what we have is the regular Kubernetes networking layer that is gonna be using instead of a port that we're paravirtualized in case of the stacking. Our Kubernetes SDN is gonna be placed on top of a port that is an SROB, and therefore we are gonna be in an equivalent case to this one, okay? That where we have the Kubernetes SDN over a physical port. So we have here our Kubernetes SDN over an SROB that is part of this physical port. So what will be the optimal solution in case of using virtual machines. Okay, in that case, we will need to have EPA Kubernetes over EPA VM. This one will have the Kubernetes SDN that will be on top of the SDN for management. In that case, access to the pods and management of them. In this case, this double layer or this stacking of SDN could not be as bad because we are not using these interfaces for data. The data we are going to be using them through SROB interfaces. How do we get to be able to provide SROB interfaces to our pods? But, in a similar way that what we were doing here, where the Kubernetes had the control of the physical port, here we have our Kubernetes having control of the physical port. How is that possible? Because we are providing the physical port in pass-through to the VM. So the physical server is giving in pass-through the port to the VM, and the VM is allowing the Kubernetes to have control of it. So it's able to provide SROB interfaces to the pods. So in this case, performance could be as good as in this one. Okay. As explained in the previous classification, it will not be as efficient because using VMs implies that we have to dedicate resources for the operating system of the VMs. Okay. And we could have certain considerations that could make this system not be as good as this one, regarding, for example, that as we have a virtual machine here, the emulated BIOS of the virtual machine could not offer the same characteristics that we have in here, and depending on the workload, in case we need real-time environments or if we need to tweak a little bit with the BIOS energy options on that kind of things, it could slightly be different this case from this case. Okay, but regarding to CPU, memory and interfaces, they will be equivalent. And that's basically the classification attending to the networking. Using Baremetal and using VMs, we could get very similar performance or the same performance, taking into account those considerations for specific workloads. If we use EPA and networking in the appropriate way.